Think math.
Let us draw the logarithm with base 2, but feed it a negative number, or 0, and no answer comes back at all. So this graph simply does not exist to the left of the vertical axis. Why is that? Log base 2 of x asks how many times 2 has to be multiplied to reach x. But no matter how often you multiply a positive number or divide it, the result is always positive. A negative never comes out, and neither does 0. So the number inside the log has to be positive. Its domain is x greater than 0. So what happens as x is pushed towards 0? 1/2 is 2 to the minus 1, so the log is minus 1. 1/4 gives minus 2. 1/8 gives minus 3. Every time x is halved, the value drops one more step. 0 is never reached, and yet the value plunges without end. That is why the vertical axis is an asymptote. The curve creeps closer and closer to it, but never touches it and never crosses it. Rising slowly on the right, dropping like a sheer cliff on the left, that is the shape of a logarithmic graph. Seen in the mirror, all of this is obvious. 2 to the x is always positive, so the exponential never touches the horizontal axis. Flip that horizontal asymptote and it becomes the vertical asymptote of the logarithm. The fact that an exponential can never give out 0 turns into the fact that a logarithm can never take in 0. So there are two things to remember. The number inside a log must be positive, so the domain is x greater than 0. And as x moves towards 0, the value falls without end, so the vertical axis is an asymptote. Both properties are simply the exponential's own properties, turned on their side. A sip of math every day here at Think Math.